Today, we're diving into a complete masterclass on the multifaceted benefits of high-speed rail, and we're taking a strictly data-driven look at exactly how we move. I mean, if you've ever found yourself just sitting there, stuck in bumper-to-bumper traffic, or maybe waiting in some packed, chaotic airport terminal, you've probably asked yourself, isn't there a better, smarter way to connect our world? Well, today, we're going to look at the hard numbers and the totally fascinating science behind why high-speed rail is literally transforming societies across the globe.
Here's our syllabus for today's lecture. We're going to break this down into 4 logical modules. First, the hidden costs of travel. Second, maximizing space and capacity. Third, unmatched energy and efficiency. And finally, the ultimate passenger experience.
All right, let's jump straight into Module 1, the hidden costs of travel. Okay, so before we can really talk about the solution, we have to grasp the true scope of the problem we're dealing with. To understand transport, you really have to understand what economists call externalities. Basically, when you get in your car and drive to work, you're producing harmful emissions and adding to traffic congestion, right? But here's the catch. You aren't directly paying for the air you pollute or the time you're stealing from the drivers stuck behind you. Society as a whole is forced to eat those costs. Left entirely to a free market, these negative impacts would never be compensated for. It's a textbook example of market failure. And honestly, this is exactly why governments have to step in. In fact, a huge chunk of the price you pay for petrol in most countries is literally just tax, deliberately designed to make people pay for the real cost of causing those emissions and that congestion.
Moving right along to Module 2, maximizing space and capacity.
Let's see how this all builds into the physical math of space. As our populations boom, the physical land we use to move everyone around becomes one of our absolute most precious resources. Think about a typical 500-kilometer trip between 2 cities. By car, that journey can take a grueling 10 hours, usually on motorways that are jammed to absolute capacity. But if you introduce a high-speed rail service traveling at 300 kilometers per hour, that exact same journey is slashed down to just 2 hours. Boom, you're there. And the data shows us that if this rail service is priced right, hardly anyone is going to want to keep driving between those cities. That triggers a massive drop in road traffic, which, you guessed it, slashes overall pollution levels at the same time.
But how many people can we actually move? Well, get a load of this number, 12,800. That massive figure is the maximum hourly passenger capacity for just a simple double-track high-speed railway. That's just one rail for trains going in each direction. By running up to 16 trains an hour, with each train holding around 800 passengers, you hit that 12,800 mark effortlessly. Over the course of a single day, that one track can move more than 300,000 passengers. That is enough to handle the absolute highest peaks of demand, unlike motorways which routinely just fail and gridlock exactly when everyone needs to use them the most.
So, the real game changer here is that rail achieves this vastly higher capacity while actively preserving our physical environment. Picture a 3-lane motorway in both directions. It needs a massive land width of 75 meters just to move about 15,300 passengers an hour. A double-track high-speed railway, it moves even more people, 16,000 passengers an hour, while squeezing into an incredibly narrow corridor of only 25 meters. That means high-speed rail uses literally a third of the land for the exact same amount of traffic. It's an absolute masterclass in spatial efficiency, helping us contain urban sprawl by using our land smartly and carefully.
All right, let's pivot to Module 3, unmatched energy and efficiency.
Transport isn't just about space, it's heavily about energy. And right now, countries worldwide are laser-focused on the transport sector to curb greenhouse gases. Let's look at a big global question. Why does the USA have the highest CO2 emissions in the world? Is it just because they have more industry than Europe or Japan? Nope. Even if they did, it wouldn't account for all that extra CO2. Well, is car ownership drastically higher? Actually, scratch that, even that isn't a big enough factor. The crucial difference, the real missing puzzle piece here, is that the USA has very little by way of railways, whether high-speed or local. People are just forced to use their cars way more, and this matters immensely. While CO2 emissions in other sectors have kind of stabilized or even gone down over the last 15 years, transport emissions are creeping up by 2% every single year. The only way we hit our reduction targets is by organizing how we move in a radically less polluting way.
Now, the sheer physics of why trains win this battle is absolutely fascinating. For the exact same journey, a car consumes 4 times the energy of a train, and a plane, a staggering 9 times the energy. Why? It all boils down to friction. A train uses steel wheels on steel rails, basically 2 hard, super smooth surfaces held together by steel ball bearings. That creates incredibly little friction, even at crazy high speeds. Plus, the train is long and aerodynamic, so it slices right through the air. Honestly, once a high-speed train is up to speed, you could turn the engines off completely and it wouldn't even noticeably slow down for quite a while. Contrast that with an airplane, which has to burn massive amounts of fuel just to get down the runway, and then keeps burning it in the sky just to fight gravity and stay up there.
To put that efficiency into a completely mind-blowing perspective, let's look at the actual pollution output. Even when you factor in the power stations needed to generate the electricity for the train, a massive 800-passenger Eurostar creates the pollution equivalent of just 20 cars. 20! And remember, most of those cars only have one person sitting in them. This means that if a train uses electricity from green sources, the pollution from running that fully loaded train all the way across the country could literally be zero. Zero pollution. And that brings us to our final section, Module 4, the ultimate passenger experience.
Let's bring this all back to you, the human element of travel. Because look, data and physics are fantastic, but an infrastructure system only works if people actually love using it. Think about what speed really means to your day. 300 kilometers an hour is a tough number to wrap your head around, so try this. Imagine watching a 100-meter running race. Now imagine those runners finishing that entire 100-meter dash in exactly 1 single second. That is exactly how fast a high-speed train is flying across the landscape. It completely wipes out the wasted time of long, stressful drives or just sitting endlessly in gridlock.
And the perks really start the second you walk out your front door. Unlike airports, which are usually shoved way out in the suburbs and force you into a long commute just to get there, railway stations are smack dab in the heart of the city. You don't have to endure 2-hour check-in lines, you just buy a ticket and walk right onto the train. Once you're on board, trains are arguably the most comfortable way to travel short of a luxury cruise ship. The ride is incredibly smooth and whisper quiet, even at 300 kilometers an hour. You're not jammed into some tiny middle seat. You can get up, stretch your legs, hit the buffet, or actually sit down for a proper meal in the restaurant car. But maybe the most incredible takeaway here is the safety. High-speed trains are actually the safest form of transport on the planet. They use these highly advanced computer signaling systems that make the risk of a collision practically non-existent. And if you're thinking that flying along the ground at 300 kilometers an hour sounds a little risky, get this. Back in 2007, France safely tested these exact trains at 574.8 kilometers per hour. That proved without a doubt that the everyday commercial speeds we ride at are a long way off from being remotely dangerous.
So, as we wrap up this explainer, I want to leave you with a final thought to chew on. We've uncovered the hidden market failures of our road networks, we've explored the brilliant physics of steel on steel, and we talked about the undeniable human comfort of a world-class rail system. The data lays out a super clear, structured case for how we can build a smarter, faster, and much cleaner world. The big question now is about the future of our infrastructure. Knowing all this, how will we choose to connect our cities moving forward? What kind of society do we actually want to build together? Thank you so much for joining me for this masterclass on high-speed rail. Keep exploring, keep questioning, and I'll catch you next time.